Hello guys, we are back with our next tutorial. In this tutorial, let's see some properties of ROC of Z transform. So the properties of Z transform. So basically I have missed a few concepts guys in the previous tutorial. I have just forgot to say you about right-sided signals, left-sided signals and middle-sided signals. So if there is something given like this 1, 2, 3, 4 and here it is given that n is equals to 0 and in a case they gave 1, 2, 3, 4 and here they gave n is equals to 0. In another case they gave 1, 2, 3, 4 and 5. In this they gave in the center. So this is called as left sided or right sided. Guys, I'm a bit confused. Just give me a second. I'll be re-verifying and I'll be saying to you. Okay, we are having the values on the right side. So this is called as right sided signal. This is called as left sided signal. This is called as center sided or double sided or two sided signals. So for this you need to find the equation, or you need to find, sorry for that guys, you need to find the Z transform. So there is nothing much to do guys. We know the formula, that is nothing but x of z is equals to sigma n is equals to, here we are having 0, 1, 2, 3, so 0 to 3 x of n into z to the power of minus n. Fine. So here we are substituting n equals to 0, so this becomes 0. So the first value will be 1 plus the second value 2 into z to the power of 1 plus 3 into z square plus 4 into z cube. So this will be our right sided signal in terms of Z transform. So similarly we'll be doing for this also. Here it is 0, so the same formula, sigma n is equals to 0 to 3 x of n z to the power of minus n. Fine. So here the value starts from minus 3 to 0. Please remember to change the limits guys, I just forgot that. Minus 3 to 0. So the first value will be minus 3, that is 1 z to the power of minus 3 plus 2 into z to the power of minus 2 plus 3 into z to the power of minus 3 plus 4 into z to the power of minus 4. Is that true? Okay, sorry, it's minus 1. It is z to the power of 0. Okay guys, so this is the other left-handed signal. The middle or two-sided signal will be in between, so it will be ranging from sigma n is equals to minus 2 to 2 of x of n z to the power of minus n. So the value 1 will be having minus 2 plus 2 z to the power of minus 1 plus 3 plus 4 z to the power of 1 plus 5 z to the power of 2. So these are the three things that we need guys. I think now everyone is now clear with right-handed and left-handed signal and two-sided signal. So let us go through some properties guys. Properties of ROC of Z transform. So the ROC consists of a ring in a Z transform plane centered about the origin x of z. Its Z transform is x of z. Its inverse transform is x of n. So it is something like this guys. For an axis there will be so many circles. So that is what we called as ROC of Z transform. Okay, so the ROC does not contain any poles guys. Remember, this is a note point to be remembered in your brain. It is not contain any poles. Okay, so now let us go through one after the other types of signals. So if x of n is a right-sided signal, the ROC is in the region of the plane outside the outermost pole. So if these two are the poles, then the ROC exists completely outside the pole. So it is greater than the largest pole. If it is 9, it should be greater than 9. If the pole is 9, it will be greater than 9. So that's the reason why we will be having in the exterior region. Fine. If it is a left-sided signal, it is inside the innermost pole. Okay, so it will be inside the innermost pole. Fine. So if the least value is minus 9, so it will be less than minus 9 guys. Okay, fine. Similarly, if x of n is a both-sided signal, the ROC is in between of the two poles. That is nothing but in between two circles. So here, these two are the main circles. So in between them, the ROC exists. So ROC, if let us assume the Z as ROC, it will be greater than or equal to 2, something like this. In between 2. Okay guys, so now I hope everyone got a small idea on this. So further moving on to the last property, if x of n is of a finite duration, then the ROC is the entire Z plane except the possibility that Z is equals to 0 or Z is equals to infinity. Okay guys, so now I hope everyone is now 100% clear with properties of Z transform. In the next tutorial, let's go through some properties of Z transform. Those are nothing but something like linearity property and all those properties. Thank you. Thanks for watching.